In this video, you will learn about friction. Friction is a force that resists the motion of an object sliding or rolling over a surface. For example, imagine you have a car that's driving along the road, and we know there will be friction between the tires and the road. And this friction is in the opposite direction of the car's motion, because it's resisting the motion of the car. We will be discussing two types of friction. There's kinetic friction, which is the friction between the surface and a moving object. For example, imagine this person is pushing this box, and because they're pushing on it, the box is moving. However, if we draw a free body diagram, we will include the pushing force and the kinetic friction force, because there will be some friction between the moving box and the surface. And then there's static friction. Static friction is friction between a surface and a stationary object. Imagine a person is pushing on a box and they're pushing and pushing and pushing, but it will not move. And the reason the box is not moving is because there's static friction that's resisting the applied pushing force. So unless the person pushes with enough force to overcome the static friction, that box will not move. Let's take a closer look at kinetic friction. You could use this equation to solve for the kinetic friction. It says that the kinetic friction is equal to the coefficient of kinetic friction, mu k, times the normal force. Let's do an example. Here we have a 10 kilogram box, which is being pushed across a surface with a force of 20 newtons. The box is accelerating at a rate of 1 meters per second squared, and we want to know what is the coefficient of kinetic friction. The first thing I always do is draw a free body diagram. We know we have the pushing force, and because the box is moving, we have kinetic friction. We also have the force of gravity pushing down on the box, and we have the normal force, which is the surface pushing back up against the box. And F net will be in the same direction as the box's acceleration. The next thing I like to do is write an F net equation. And because we have forces acting along both the x and the y axis, we will need to use an F net x equation, which is the sum of all the forces acting along the x axis. So we have the pushing force minus the kinetic friction. Kinetic friction is negative because it's a vector that points to the left. Now because the box is accelerating, we have to replace F net x with ma, and we can also replace the pushing force with 20 newtons. Now all we have to do is rearrange and isolate for the kinetic friction, and then plug in our values for the box's mass and its acceleration, and we find that the kinetic friction force is equal to 10 newtons. Now we know that kinetic friction is equal to mu k times n. We are solving for the coefficient of kinetic friction, which means we need to determine the normal force. Well, we can use an F net y equation. This would be the sum of all the forces acting along the y-axis. So that would equal the normal force minus the force of gravity. And the force of gravity is negative because it's a vector that points down. Now we can replace F net y with 0 because the box is not moving up or down, so there's no net force along the y-axis. We can also replace the force of gravity with mg. And then all we have to do is rearrange and isolate for the normal force. And we find that the normal force is equal to mg. I'll just plug in my values for the mass and the acceleration due to gravity, and we find that the normal force is equal to 98 newtons. And now that we have the normal force, we have everything we need to solve for the coefficient of kinetic friction. We just need to rearrange our equation and isolate for mu k, then plug in our value for the normal force, and we find that the coefficient of kinetic friction is equal to about 0.1. And that's how you use the kinetic friction equation to solve forces questions. Now let's look at static friction. Static friction has the equation Fs is less than or equal to mu s times n, where mu s is the coefficient of static friction and n is the normal force. Now you might be a little confused. Why does it say static friction is less than or equal to? Well, that's because the static friction can change size, and it will change size based on the strength of the applied force. So imagine the person is pushing the box, but the box will not move. Now if they're pushing with a force of 5 newtons, that means there's a static friction force equal to 5 newtons. Now what if the person pushes even harder? So now they're pushing with a force of 10 newtons, but the box still won't move. Well, that's because the static friction force increased to 10 newtons, so it's still resisting the applied force. Now, what if the person pushes even harder? So now they're pushing with an applied force of 15 newtons. And finally, the box moves. So finally, the applied pushing force is greater than the static friction, so the box moves. So what we just learned is that the static friction force can increase in size up to a maximum point. And once the applied force is greater than the maximum static friction, then the object will move. And so when you're doing questions about static friction, we only care about the maximum static friction. And so you will use the equation Fs max is equal to mu s times n, because this tells us the minimum amount of force that must be applied in order to move the object, because the applied force has to be greater than the maximum static friction. Let's try another example. So imagine a person is pushing a 15-kilogram box, but the box won't move. If the coefficient of static friction is 0.12, we want to know what is the minimum amount of force that the person must apply in order to move the box. Now the first thing I like to do is to draw a free body diagram. We have the pushing force, we have the static friction, we have the force of gravity, and we have the normal force. The next thing I like to do is write an F-net equation. And because we have forces acting along the x-axis and the y-axis, we will have to use an F-net x, which would be equal to the pushing force minus the static friction. Now because the box is not moving, F-net x is equal to 0. And if we rearrange this equation, that means the static friction is equal to the pushing force. And we can expand this to write that the pushing force is equal to mu s times n. Now we have the coefficient of static friction, but we don't have the normal force. All we need to do is use an F-net y equation to solve for the normal force. F-net y would equal to the normal force minus the force of gravity. Because the box is not moving up or down, F-net y is equal to 0, and the force of gravity can be replaced with mg. If we rearrange this equation, we find that the normal force is equal to mg, and when we plug in all our values, we find that the normal force is equal to 147 newtons. Now that we know the normal force, we can plug it into our equation, and we find that the pushing force is equal to about 17.6 newtons. And that's the minimum amount of force that the person must apply in order to move the box. And so now you know about kinetic friction and static friction. Try the questions I've posted in the forces unit to test your understanding.